Okay, so some students we've had before. Your name is?
Henry Chan.
Henry.
And I'm George.
Okay, sorry, a bit close there. Right, tell us about what your final year BE honours project is.
The project is about building a power supply, a low noise one for a hybrid amplifier.
Hybrid meaning half valve and half
Solid state.
solid state. Okay, that's interesting. This is for your own business, really, isn't it? I think you've got a company, or yes.
The Class D amplifier needs a 30 volt input and it can output 360 watts RMS, which means a peak power of 720 watts. It's going to drive two 4 ohm bass and two 8 ohm full range speakers.
Okay.
And then
Has it got to be very smooth, the supply? I mean,
Yes.
the ripple and everything.
if it's not smooth, then there's some noise when there's no audio input, and the sound quality won't be that good.
Okay. So did you have any measurement of what sort of signal to noise ratio or ripple factor you have to get?
We don't have any measurements, but we should make it as low as possible. So as long as the final product there isn't too much noise auditable, so it's all right.
Okay. So which one is the amplifier? Which one is which? They got a.
So this is the PFC,
What's that? The pulse.
power factor correction
power
board.
factor.
And this is the LLC converter.
Power factor correction. So what's the? I know what power factor correction is, but why do you need it here?
We need the power factor controllers to boost the input voltage to a fixed 390 volts from 85 to 265 volts AC. And the AOC technology chosen, it can only operate on a narrow input voltage, but we chose that because the IC chips are very cheap.
So what's this bit again? This board?
It's the AOC converter, which outputs a 30 volt.
LLC.
It's a inductor, capacitor, and a transformer,
Ah, yes, for filtering.
and it's a resonant circuit.
Okay, I'm with you. Yes.
And that resonant circuit acts as an impedance divider. So when you change the switching frequency, it changes the voltage across the transformer.
So why is it behind this protection? Is it high voltage or something? Why is it?
Because it's all exposed, we have to follow the university safety rules.
Yes,
so
it's 380 volts
Oh,
out of there.
Oh, I see.
Yeah.
I see.
it's
Oh,
gotta
that's
be-
fair. I didn't realise it's such high voltage. That's because you're powering valves and so on, isn't it? Yeah.
We need a power factor controller to prevent the switching noise from going back into the mains.
Okay.
Otherwise, if the customer's audio source runs off the same mains, then they'll have a distorted input voltage,
I see.
and that means the audio source will have some noise.
It's quite a hefty, big board, though, isn't it? I mean, wouldn't that be quite expensive? All this to. I suppose these things are expensive anyway, aren't they? These are high end.
For all of the parts, it can be cheaply gathered from China, but we still have to use genuine control IC chips and maybe some MOSFETs. But just for a switching transformer, it will cost maybe $1 or $2 each.
So how much would it cost you to manufacture this kind of thing, do you think?
So the PFC controller, I've done the calculations. If all the components are genuine, it should probably be around like $80 to make the whole thing.
Okay.
Yeah.
But for the actual thing, we're going to use as much SMD parts as possible because there's a fully automated SMD installation machine.
Okay.
And so for the actual thing, we're going to use more of the Chinese components, and even the MOSFETs, we could possibly get reliable ones from China. So the main cost would be just the genuine control IC chips. The power factor controller is around $8, and the gate driver for the power factor controller is around $2.
And have you tried it on the real thing, on the amplifier yet?
We haven't tried it yet, and we still need to fine tune it, but we don't have enough time to
Okay.
do that. We started off with only knowing basics of switching, and we don't have any experience, so we spend a lot of time researching.
Thanks very much then. Okay.